Hello everyone. Thank you so much for taking time and joining us on this webinar today. I see that people are still joining in. We will get started in a minute. Okay, let's get started in the interest of time. A small note for all of you joining in. This webinar was supposed to be done by our VP of Products, Vivek, but unfortunately he could not make it. So we have our CTO, Karthik, who will take you through the presentation. Okay, so um, with that behind us, hello everyone. Thank you so much for joining us on this webinar today, where we tackle a question that is probably on the minds of most CTOs and engineering leaders today, which is APIs. Now, we will cover at length how you can protect APIs, and even before you protect them, you understand how to discover APIs and classify them. So, Karthik will take you through the webinar, and then he will also do a small walkthrough on how we do it on the platform. So before we get started, a brief note about Induspace. We are an application security firm helping protect more than 6,500 customers' websites and APIs worldwide. Primarily speaking, we have the application protection platform, which is AppTrana, and we also have the risk detection platform, which is Induspace VAS, which is a dashed scanner for websites and APIs. Right. So over the years, we have been recognized by various analysts, and we also have a lot of compliance and certifications in order to help our enterprise and SMB customers worldwide meet compliance. Now, this is just a representative sample of all the customers that we have across various industries. Should you need a reference, please reach out to us, and then we can arrange for a reference call. Now, just one slide on the research reports that we publish. Every quarter, we publish a report called the State of Application Security. This analyzes trillions of requests that are processed on the AppTrana app, and then out of those, we analyze billions of attacks and give you trends like what API attacks have been there, what DDoS attacks, bot attacks, and so on. And this has been covered quite well across various national and international outlets. So if you are interested, please go to induspace.com. There's a research report section, and from there you can download our latest report. So without further ado, let me introduce our speaker for today, Karthik Krishnamoorthy, who is the CTO of Induspace. He has close to 3 decades of experience in building highly technical security software across industries and various other companies. He oversees the technology strategy and product development at industries. And before this role, he was instrumental in building our dashed scanner close to a decade back. Now over to you, Karthik. I am stopping to share my screen, and then here you go.
Thank you, Phani. Good, kind words. Today we will talk about API discovery classification and why that is so important for security for most organizations. In fact, all organizations, because I almost can't think of organizations who don't have API server as part of their business or as part of doing business. Either they provide APIs or they consume APIs. APIs are generally used everywhere nowadays. So this is what we're going to talk about. So without further ado, let's just jump right into it. As I'm sure most people know, even from an intuitive thing, even if they haven't read studies and data, APIs are growing fast. The increase in APIs are crazy. There was a study that says that growth in API requests is 160%. And this is 6 months back, 8 months back, right? Ditto for the other side of things. When there is 800% increase in AI-related APIs. What that means is AI, it happens in two ways, right? It's APIs that are actually providing AI or chat services to end customers, but more so also that now the APIs are not necessarily consumed directly by UI or by other services provided by the organization themselves. It is consumed by AI. It is consumed by AI bots. It's consumed by AI services. It's consumed by LLMs and so many other services that now AI is enabled and everybody is embracing. And remember, both of these statistics is actually from months back, and I'm sure it's only increasing and not decreasing. Right? When we talk about growth in API request volume, the other thing also very interestingly is that most organizations, fully 90 plus organizations have reported that they have problems in APIs, and well over a fifth of them have reported some kind of breach in their API. Reported means reported for the survey. Unless it's really big, it generally doesn't hit the news circuit kind of stuff. API calls also interesting. Countries like US, UK, Germany, Netherlands, and India are the top 5 in AI usage or AI related API usage. So it is increasing and is being adopted faster than we even though we know it from all the Geminis and the Chat GPTs and the Anthropics out there, it's still used even more than you would imagine. Moving along, what is the problem with APIs, right? The big problem with APIs are that, APIs are great. They enable it and it's great. We are totally not against APIs in any way, shape or form, right? APIs are needed. This is how things, things mesh together. You can expose value, you can expose values, you can charge for them, you can get users to use it, you can use other APIs. APIs are great. But the problem with this proliferation and probably due to AI, and whether it's used in AI or AI being used to do stuff, is that the big problem is that organizations have less visibility into the APIs. This is because of the number one attack vector in a particular study, right, is shadow APIs. APIs that the organization knows about and publishes and consumes. Once they know about it, generally it falls in the governance. At least there's some level of oversight into it, right? Different organizations might have it as better or worse, but at least there's some governance. But there's a big percentage of APIs that the organization doesn't even know about, and these are called shadow APIs. How does this happen? developers create APIs or modify existing APIs, and every time that happens, there could be security issues with it, or inadvertently exposed and things like that. They could be and it's with the pace of development, trying to expose value or discover new value with your existing business. This kind of race, generally what happens is APIs get changed very frequently, or at least much more frequently than it used to before. So when this happens, this definitely you start having problems with the APIs, with shadow APIs. Another thing is zombie APIs. New APIs come, old APIs are not actually removed, kind of stuff. It's there, nobody's using it, so there's less governance, less level of oversight over it. So these kind of things, it's never okay to say that, okay, I've made my API specification, I've discovered my APIs. Once we're done, APIs change often, new APIs, API parameters changing, new functionality exposed, new these kind of things generally means that you have to continuously discover. Otherwise, you will never know what your risk profile even is. Now, the other thing is that, again, it's not just the APIs and shadow APIs. It's also that, okay, you have APIs, you know your APIs, but do you really know what each API is doing from the point of view of compliance or sensitivity? Is this passing a credit card? Is it passing a credit card correctly? Is it responding with the credit card? Is it tracking PII data? Different countries, different regions, different depending on which compliances you are subject to. There definitely is various things you're allowed to store, not store. How it should be transferred are pretty much specified in many other. Whether for credit cards there's PCI, for other things if you're doing medical data there's HIPAA. There's so many this thing, right? Europe has different or stricter things. US has different. India has different. There's a lot of compliance things, but all of them pretty much come under the thing of, hey, if you have handle sensitive data, there's what is sensitive and how to handle it is specified by them. But most importantly, for an organization, they need to know which APIs are sensitive and which APIs are not. And this is something that they find it difficult keeping track of. It's tough enough keeping track of APIs and new APIs and changed APIs. Now you have to also figure out which ones are sensitive, which parameters are sensitive, and which new APIs have sensitive or more exposure, kind of stuff, right? So this is generally a big problem, and these are the impacts are pretty high. Why do organizations find it difficult to keep track of APIs? Right? I think we talked about a little bit in the earlier slides as well. It's the development team, the organization, the business, generally their mindset, their incentives, their priorities generally are to quickly evolve, quickly deploy, quickly this thing, so we can catch the latest trend. You can catch this opportunity, get this opportunity, sell more, get more customers, whatever, right? These are generally the kind of race that many I suppose most businesses are in. If it's a large enough organization, there are multiple teams, each one working on the same API or different APIs. So the cadence of API shipping also has gone up now. And it's easy to do CI/CD and deploy changes, small changes, big changes quickly, kind of stuff. So it's almost continuous that there is this kind of deployment. And organizations definitely don't want to add speed breakers any more than they have to, right? They're absolutely this thing, right? Things that impact velocity. Each API, each change can't take a long time to go through review or multiple levels of review before it goes out. So there is that pressure also, and well justified, by the way. It's businesses are not doing it only for their own security; they're also doing it to actually work for their customers and get money, right? That is the goal of the business. Developers sometimes test APIs, debug APIs, do leak out, which should not be exposed to public, but it does get exposed. And there is also another problem is that it's not only APIs created by the organization that is used outside. It's also third-party APIs, partner APIs that also get that also can be the point where which are used more than more than you think, or more than anybody knows, and that's why those also are avenues or exposure that is there. Here's some, couple of high-profile things that happened in the last few months. So Swissborg is a cryptocurrency platform, and they actually were using a third-party provider called Kiln, which was doing the staking for them. Right, it's a cryptocurrency platform. So a vulnerability in the third-party this thing actually exposed whatever, about 200,000 Solana tokens or coins, and I mean, it's like Bitcoin but not quite, and that actually cost them about $40 million, right? It's a big amount of money that got lost because of the third-party API vulnerability. Another thing that actually hit the news some time back was McDonald's. McDonald's was having a chatbot to hire people for McDonald's. I'm not sure. I think it's interns or this thing, and the AI powered chatbot actually was helping with interviewing or at least screening and things like that. So it allows the candidate to chat with it and then get into these things, answer questions, screen, prioritize people, and those kind of things. So in this case, the AI bot itself wasn't specifically targeted, or it didn't have the problem, but the backend system, there was a combination of things that are used to do it. There's a very, very weak password used. The details are there if you Google for it. And along with that, there was an IDOR, insecure direct object reference vulnerability, because of which anybody who could log in with this weak password, which pretty much anybody could, suddenly had access to all sorts of resumes, not just that particular franchise or that particular manager's pool of this thing. They were able to get private applicant details or PII kind of details for all the applicants or millions of applicants, right? So this is another big thing that was a problem that happened recently. This is why this is where API vulnerabilities can actually have far-reaching and big effects. So we know all the problems. How are we going to protect APIs, especially at this scale, right? Like I said, fast changing, use this thing, high volumes probably, and stuff like that. So number one thing is, you have to discover, you have to know what APIs are there. You have to find shadow APIs, zombie APIs. You have to know whether these APIs were, was something the organization has actually explicitly allowed. You have to know which is deprecated, these kind of things, right? So you need to do this. You need to be able to classify APIs based on risk. Just because if you have so many APIs, you do need to focus on the core ones, where the ones that expose sensitive information probably will be very high. The ones that gives you a lot of access will probably be higher in the list of a list of things. So these are the kind of things that you have to be able to classify. So that, I mean, in an ideal world, you will do all APIs perfectly all the time. But in the real world, that doesn't work, because this fast pace of development, this huge amount of APIs that are there, means that you have to at least focus really high on this. It's always the cost benefit kind of stuff and a time to time kind of stuff, right? You can't do everything today, or you can't hold back deployment until all of these things which are pending for a while have been done, right? So classification and prioritization really is needed. I mean, anybody actually running security for APIs and stuff knows this kind of stuff, right? That you cannot always do everything all the time. You need a scanner. No matter, I mean, most organizations, right? Again, they have a deployment thing, they have developers, but they are not security experts. They might have security teams handling the edge and typical stuff, but API security, vulnerability, thinking like an attacker is a very different way of doing things. So regular scanning is needed to to find problems, to classify, to discover new things. All these things, I mean, regular scanning for that, and regular vulnerability scanning to find out, hey, the API changed. Now, does it expose a vulnerability? So you can't just scan once and then, do it again after, after a long time or something, right? There's two things that happen in any kind of scanning situation, right? Two things can cause a vulnerability. One of them is your code changes, your API changes, your backend changes, or something along the backend changes, right? In terms of the layers of technology that goes between the request and the actual code that serves the request. The second thing is that new vulnerabilities come out. There could be a framework you're using that a new 0-day comes out, a new vulnerability comes out. How fast is your team going to be able to look and check and see whether they're vulnerable? A scanner, it's a full-time job to keep on top of these kind of vulnerabilities. Obviously, on the other side of things also is protection, and there is protection in various ways. But one of the best ways to protect is positive security, right? Typical pattern-based protection will block things that is known as bad. So you try in a SQL injection or a particular kind of thing. Based on those patterns, it will block it, which is great. And this is obviously, it's not like, I'm not saying don't do it, or it's a wrong thing to do. We do it, everybody does it, and it's the right thing to do. If you know it's bad, why would you allow it, right? That's kind of basic common sense. But a much more powerful thing, which works obviously way better in APIs than in web kind of traffic, is that it's positive security control. I mean, the difference here is you allow only the known good things or known good type of traffic, shape of traffic, versus block the known bad, right? There's a very different this thing. We'll see it actually as part of our portal thing. But I mean, as a very, very simple example, if we know that this particular parameter is an integer in the range, blah, 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 right? Or a string which, we know that it's only between, say, 10 and 15 characters. Why would you allow arbitrary strings there? So the minute you restrict it to this, suddenly your attack surface has gone down really small. While there are attacks, obviously, with integer overflow, underflow, and all these kind of things, right? With ranges, with this, if you can do this correctly, you just make it that much more difficult. Giving a smaller string means even if you can be attacked, there's only so much you can do with 10 characters kind of stuff, right? Again, it doesn't mean you're 100% protected. Protection, actually, the right protection, it requires a lot more. But it'll at least make it that much more difficult. There'll have to be a combination of attacks, a chain of attacks, which will actually lead to a real compromise, as opposed to allowing it all in one big thing, right? It always reduces the attack surface. And of course, from an organization point of view, you want to know what all APIs you have, what are your shadow APIs, what is your, what kind of traffic is it handling, so you know how whether it is protecting, whether you should make sure that you're compliant with X, Y, Z. These kind of things, as the API changes, you want to know that it's changed, so you get to say, okay, these APIs have to review again, whatever it is, right? All of these things, you need to be able to track in a central place, because multiple teams, multiple APIs, multiple deployment cycles, it'll going to be impossible to have a process where people actually, notify, get it reviewed, kind of stuff. It doesn't scale as well. Okay, so hopefully with this kind of background in mind, I can jump right into AppTrana portal and show you a lot of the things that we've been talking about in the earlier slides. So let me just quickly switch to the AppTrana portal and show you what's happening here. Okay, let me just log in here. And okay, so this is our dashboard. This is where you start up. I will, there's a lot of other webinars, a lot of functionality here, a lot of other webinars talking about the amount of functionality and the amount of things that we do in various areas. But this webinar, we are going to focus on API security. So when you go to API security, this is what you see when you start off, right? AppTrana does continuous discovery of the APIs that you've onboarded. Continuous discovery means we are always inspecting traffic. We're discovering traffic. Once we have enough data, we will discover parameters. We will discover path parameters, URI query, post body parameters, and we will we will also scan it for tags like PII and those kind of things, which also I'll show you. And this is happening in a continuous way. So anytime a new API comes up, it will be shown. Anytime modified API comes up, it will be highlighted, so you know that you have to go look at it and address it. And what I mean by that is, if we actually go down to this kind of stuff, right, and scroll through, you see a lot of APIs are there. Some are pending, some are approved, and I'll show you what that means, kind of stuff, right? So let's look at what kind of API things gets discovered here. So this is an already approved API, but in general, you can add tags in case you want, like, you call this like a marketing API or a customer feedback API, whatever you want to, or a particular region or a particular business group. You can tag it by, you can create your own user tags here. In the details here, all the methods that were discovered that were using this API are shown. The get has, as you can see, it's actually the query parameter called size, which is an integer. We've already discovered that. Options has no parameters, and the post has these parameters discovered as string or integer or whatever type. In this case, these are types discovered. So we've already automatically discovered all this. The user generally, I'll show you in the other screen, generally will look at it and then approve it to say, yes, you've discovered this correctly, this API is correct, and stuff like that. And then the policy enforcement can take place, which is, you want to enforce specific things. Okay, you want to enforce protection on the path parameters, or don't even allow this API. This is an old API, don't allow it. Don't allow new methods, which means, okay, you've discovered that there is, in this case, there's get options post. Don't allow a put in this case, right? Or any other method that comes up, don't allow it. So this is high level. This is all your discovered APIs. You've obviously 11 have been reviewed and either accepted or blocked. Let's look at what the user generally will do is look at the APIs awaiting a review, and they'll go through it and look at it. Okay, do I understand this? Do I know this? Like, for example, if you look at this what is it? The basket REST/basket API, you know that it's got a path parameter, and it's pending review right now. It's an authenticated API. You look at their details, and param1 is integer. The user will go back either directly or talk to their look at the API documentation, or talk to the development team if there's no API documentation and say, hey, by the way, REST basket, it is an integer, right? What's the range? Let me know. Is it an integer? And then decide if they want to again enforce it and save it, kind of stuff, right? This generally is the flow for all the APIs awaiting review. The other thing that comes up, of course, is sensitive APIs. These are APIs that we have identified as having sensitive information like email or address or something like that. If you actually look at it, you might see, like in this case, it is credit card expiry full name. That's probably why the PII got triggered. Credit card information got triggered, and this is how we'll tag it and say that these are the kind of things that is available in this or exposed in this kind of stuff, right? Once you see all this, once you know that this thing, the other thing, of course, is protection. So we have API protection, what I just talked about for positive security and all built in. You can select the API and apply the protection, enable this thing, right? So here, as you can see some APIs are blocked right out of the bat. For some APIs, you're blocking new methods, which means in this case, get and options are allowed. But if somebody tries a post instead to bypass something, it will not be allowed because you're blocking any new methods that I don't know about. Options generally in many things are allowed in the modern thing because there's a pre-flight check. So it's difficult to block options in many cases. But obviously, since we've detected it, we can say, hey, in this case, options was never used. Don't worry about it. You can block it, right? In some cases, APIs are blocked outright. In some cases, we say, yeah, don't allow path parameters. Sorry, it's not don't allow path parameters. This is actually what we are saying here is actually that the path parameters will be inspected and blocked. We're not like blocking all path parameters, but the path parameters will be enforced, and then malicious things will be blocked, or if it's out of range, it'll be blocked in the positive security. The The last thing that I want to show you in this is API scanning, of course. So the way that API scanning works is that the user has to upload a Postman file to give, the request and parameters, because you can't just guess at all parameters and hope it works for an API. Like, for example, if there's something about product ID, you have to know what a product ID is and not a random thing. And while we discover APIs, we will never be using product IDs or customer IDs or anything that we've seen in production is never fed back here for obvious reasons, for the damage it could cause. So you choose which APIs you need to scan for and upload from the Postman file. Once you upload the Postman file, you see all of these. You choose what you want to scan for, save the changes. In this case, I won't do that because I've already done it, so I'll show you the scan. And then you can go to Manage Scans. Now you go to Manage Scans, and regular scans are happening. To start the scan, you'll click API Scan, which will take some time to run, a couple of hours. Once the scan is completed, you will see all the vulnerabilities that are found here. Like, you will see so many vulnerabilities, error message. Many of these are automatically patched here. I will, if you see some of these, like, I'll actually show you one more thing before I come back here. But for many of these, if it wasn't patched, you could request a custom rule. You could view what was actually found in this, and this kind of stuff is, you can see the mix of manual pen testing and API scan directly in this particular case. API scan means it's automated. Manual pen testing is manual pen testing, and there's a whole bunch of things happening here, right? So if I were to even go to this thing, right, the other thing that we have along with vulnerabilities and patching, right? Because we have in its interface, because the AppTrana product actually has a scanner and protection in the same software, in the same package, in the same solution. What happens here is that what we scan, what vulnerabilities are found. We can automatically tell you that, okay, these are blocked by our rules. And we don't just tell you by our database lookup, we'll actually run it through our protection and see that it's blocked. Where it is not blocked by default, in some cases, certain rules are not blocked by default because their false positive chances may be slightly higher. Bulk of them will be blocked by our regular protection, SQL injection, abuses, command. A lot of these kind of things will be blocked out of the box. But since we are a fully managed service, what happens is you can request a custom rule. So in that case, they can write custom protection for certain things that are not enabled by default. Once that is done, it is a rescan is done through this through this protection with the custom rule. So we verify not just that the specific vulnerability with that particular vector was blocked, but also that all other variants, all other vectors, all other encodings are also blocked. So you're fully protected and not just a specific use case is protected or specific attack vectors protected. Once we do all that, we will actually be able to issue a Swift Comply report. A Swift Comply report is, I'll just show you this. So this is based on the scan. So we can say that, look, your patch for all these vulnerabilities are there, but it's not exploitable because AppTrana is blocking it in all cases, right? There will be a couple that cannot be blocked directly off the bat, and those need to be fixed in code. And I will, like, for example, I think we saw something here which was, where was it? Easier to understand, say failure to restrict URL access, right? So if I actually look at that, you will see that in this case, this particular thing, like application configuration, it's an admin API, but there's no authentication. So anybody can access it. So this is not something that that we will block off the just by default, simply because it's probably an API that is used by admin tools and for other things. But so this is, we say, please fix in code, add some access restriction, add some role-based access control, do something about it, right? So, but the bulk of it is like say out of these 35 vulnerabilities found, there were 2 fixed in code. In most cases, the bulk of it is fixable by AppTrana's virtual patches, and a Swift Comply report. Our guarantee is that we will give it to you in 72 hours. This report is accepted by compliance auditors when they're doing your certifications as mitigating control, and you can get your certification even while you go ahead and get the actual APIs fixed, which sometimes takes time because it need not be your API. It could be a third-party API. It could be you're using an older version that doesn't have patches. You have to upgrade. All these things sometimes takes time. So the mitigating control is accepted and it keeps you fully secure. Okay, that being said, let me move on to back to the presentation, and here's a nice use case or a case study kind of stuff, right? We actually have it on our website. I think somebody can paste the link to it where it's more detailed than the slide. So this is one of our customers, a fintech large company, and they had the problem was they had a lot of APIs. They had quickly evolving APIs, and the APIs exploded, and it was very difficult for the security team and the ops team to have any visibility into what the APIs were, what are they classified as. They had problems with volumes, DDoS, bot abuse. They had a lot of bot traffic, which obviously increased cost and always increases the chance of a compromise or this thing, right? Which is pretty bad once it happens or if it happens. Their existing gateway solution could not have that kind of fine-grained controls in the endpoints. It was, very, very broad kind of stuff, which didn't work for them because they have a lot of end users and apps and those kind of things. So what they needed specifically was protection, and the protection that can work at the scale they're working on because they have very, very high volume in terms of traffic. So once they used the interface solution, they used AppTrana. They got the visibility, discovery, and risk-based classification like we just saw in the demo, continuous monitoring, continuous protection, continuous discovery. And the positive security immediately brought down the attacks, as in the traffic wasn't even reaching the servers. It was being scrubbed at the AppTrana end, at the AppTrana layer. DDoS and bot abuse, with AppTrana solution, our AI-enabled solution, or AI-driven protection, cut down all of this, right? So they were absolutely not impacted, and they see only the clean traffic, right? So they dramatically cut down their cost, their exposure, their problems in terms of bot traffic and DDoS and stuff. So what is the AppTrana API platform, right? So it's a full loop, right? It starts with discovery and classification, scannings for vulnerabilities, like I showed you, API protection, including positive security models, so that will automatically, block attacks, scrub your traffic, kind of stuff. The other thing about AppTrana is that it's unmetered for protection, which means your DDoS attacks, your bad traffic, we charge you only for traffic that continues onto your server. The bad traffic that is blocked is not charged. Our solution is very unique among competitors or among similar solutions, or is that we can deploy in block mode right away. We don't have this thing where we deploy the thing and let the customer decide when to move to block mode. And because often what happens is that as the APIs evolve, as the customer and the team doesn't want to make the call to block like this, you kind of end up in this continuous tuning, never blocking kind of mode, right? It stays in log mode for way longer than it has to until only very, very few APIs become in block mode. In our case, because of a long history and a managed service, we deploy in block mode right away and quickly. compliance and the Swift comply you've seen, it's, thanks to all this and our automations and our AI models built up, we can actually get you the compliance within 72 hours. And it's a fully managed service, like I said. And, and this is the full loop, right? So this is continuously, right? As the APIs come in, goes through this whole API discovery classification. This whole loop keeps happening. Thank you. That's about it. We can turn it over to any questions if you have it. Thank you.
Yeah, so look like we only have 1 minute, so maybe we'll take one question. Um, by the way, there is a poll question that we are asking if you would want a demo or a free trial. Please vote on that. Meanwhile, we'll take this question. Um, okay, so the question is, how does API security pricing work? You want me to take that, Karthik?
Yes, go ahead, Phani.
Yeah, so we just have two levers. One is on the number of API hosts that you have. And the second thing that we do is we bill for the bandwidth that passes through the cloud, because we are a cloud WAP. So these are the only two levers that we have for pricing. For example, behavioral bot, managed service, positive security model automation, all of that is included in the pricing that we have. There are no add-ons or surprises. Like I think Karthik briefly touched upon the unmetered DDoS aspect also, where we bill only for the clean traffic that hits your origin server or the API host. That is how it works. Karthik, do you want to add anything to that?
Oh, no, I think yeah, you got that covered actually in terms of pricing. Yes. So
Okay. Probably one is from a current customer. We already have a WAF. Do we need to procure this feature once again? So if you are an Indus customer, then API is a separate license, because the capabilities including API discovery, API behavioral DDoS bot, and the managed SOC aspect of it are different. So yeah, but it's like anything, right? So since we bill on the number of applications, now if yours is a separate application, you need to take one more license for the application. So it's same whether it is you want to add a new website or a new API host, it will be a yeah. So it will be a separate license that you need to take. Okay, does your SOC team monitor API specific attacks 24/7?
I mean, I guess the short answer is yes. It's like in terms of API or web attacks or whatever, we give the same service for both kind of stuff, right? Which means obviously our AppTrana automated solution is taking care of most of it, but it's being monitored in case there's any kind of spikes and stuff. It's exactly the same thing. I mean, the experience in that sense will be exactly the same as you would for the web traffic, non API traffic kind of stuff.
Yeah, and just to add to that, right? So we guarantee 100% SLA that is there on your contract. So that is something that we guarantee, because we have plus a human team monitoring your applications for any anomalies and attacks. Okay, I think we are 3 minutes over time. Maybe what we will do is, I think we had a few more questions. We will reach out to them individually on the email. Anyway, thank you so much everyone for taking time to attend the webinar. So as always, please sign up to our newsletter on the website, where we will send you notifications on many such webinars. And then, yeah, see you next time. Thank you so much. Take care. Bye bye.
Bye.